is a lecture that I've organised for my students at UWA, the Masters of Design students. We're investigating pathways to net zero carbon. And I came across this project, that is a house for David Sutton and his wife. And they've engaged John Wardle architects to design their home. This is the 5th house that David and his wife have commissioned, and it's their 2nd passive house design project. And when they came to John Wardle Architects, they were looking not just for a house of design excellence, which we're all familiar with. I'm sure you're all familiar with John Wardle's work, but they also wanted a house that was really pushing the limits of current sustainability. So again, looking at a passive house designed home, but also a home that's following the Living Building Challenge. And David and Diego, the architect, will talk to us about that today. I'd also like to introduce Diego, who is, I'm sorry, Diego, if I muddle this up, but you're Associate Principal at John Wardle Architects, and you've been heading the housing sector for about 19 years. Right. And so Diego led this project, the Limestone House. So apologies for that messy introduction and apologies for our late start. I'm going to hand you all over to David, the client, and Diego, the architect, to talk us through the Limestone House.
Well, many thanks, Gemma. It was a great introduction given the dropping out of your computer. So thank you very much for that. I just want to, I'm so pleased Ben Hohnen's on the line, because it was Ben who had the foresight to link us up with you. And we thank Ben for that very much indeed. And we'd like this to be, I hope all those listening will get something out of it. We will walk through what we've got prepared, and Diego has a big presentation, but please do it if you so feel, and especially you, Gemma and Sam, if you feel that there's something which will help your colleagues and friends while we speak, please do butt in and ask questions. Gemma asked me just to speak a little bit about our journey towards engaging John Wardle. The first thing, I guess, which is a little unusual, rather than going straight to an architect with our ideas, I first engaged a fabulous guy called Nick Bishop, who was an environmental engineer, and asked him to set out, I guess, the best state-of-the-art certification systems and water supply systems, and water treatment systems, energy systems, materials, you know, the best in class worldwide. And he did a fabulous job, and I've sent that paper to Gemma, and I'm very happy to share it, because while it's now 4+ years old, it still provides a great body of knowledge which can easily be updated. So should you wish to receive a copy of that and anything else I mentioned during this talk, please do ask Gemma, because while we were perhaps earlier than some, we've done a lot of work that we now want to share with people, whatever projects you're undertaking. So when Nick came back with that report, he had, in relation to certification systems, he had the normal bank of Green Star energy type certification systems, but one was outstanding. It was called Living Building Challenge. And it was the most holistic of the lot, not just energy, but covered water, materials, place, health and happiness, beauty and equity. And because I guess the challenge was laid down, we went for it. And from that, we issued an architectural brief to perhaps a dozen of the best architects in town. And we interviewed them. And in the end, we selected John Wardle. And I'll tell you later why that turned out to be a very good choice. I guess it's worth noting, before all this, I had looked at hundreds of, I had the luxury of looking at hundreds of blocks of land in Perth and Melbourne, looking for an east-west axis, I should say, where the northern light couldn't be blocked. and in the end found one, on which we've now built. When you're working with your clients now and clients in the future, every block, of course, has its northern the northern light attributes, and all I can say is that I know you will all, as professionals, work as best you can to maximising the position of your buildings in relation to northern light, etc. And Diego will talk about that a bit more later. To the LBC, certification, which is to lie at the heart of the design by John Wardle, we also added Passive House, which is really a subset of the energy petal of LBC. And also because I'm an engineer, and while I love beauty, I'm also an engineer who loves, efficiency. We added prefabrication to minimise waste and all the obvious benefits of no weather problems, etc., while the house is being fabricated. In relation to net zero emissions, which I know is the focus of this discussion, we chose LBC as a structured path towards net zero. And I guess after the presentation, I'll tell you where we've got to so far. We're in the house living very comfortably. There's still work to go. The batteries aren't in yet. And I was talking to the engineer called Lai, who Nick Bishop put us onto. They're now called Integral, but I was talking to Shane yesterday. We will address the certification of Passive House and LBC in due course once all elements of the house are finished. Now, having raced through that, Gemma, unless there are any questions you have, I'm happy to hand over to Diego, Gemma.
That sounds great, David. I think we'll save our questions to the end of the talk.
Okay, great.
Yeah, thank you.
Good. Thanks, David. That was a great introduction. I think probably one of the interesting things about this project was that despite David and Kate having very strong ideas in relation to the sustainability paths that they wanted to take, they were also very keen to make sure that in a way there was a very strong approach architecturally based on their brief and their site and what was best for that particular block. But of course, as curious architects, I guess we started looking very quickly into some of the key drivers for both Passive House and Living Building Challenge, and to a degree, and particularly with Living Building Challenge, that proved to be quite a good thing to do. There's a lot of technical aspects to both certification methods, and David kind of touched on the Living Building Challenge, and I won't go too much in depth into it, but suffice it to say that it's a really holistic initiative. I'll talk a little bit more in detail a little bit later about it, but it really covers energy, water management, materials, beauty. There are so many things, and it's really quite a recuperative type of standard. It's not looking at doing, not too much damage, as is kind of the case for most legislation in this country, but it's really about having a very proactive approach. So there was a number of things, I guess, that were salient. So there's a lot of these petals that fall under the Living Building Challenge, but there was a few key ones that I'll go into a bit more detail later on that really affect an architect's approach to a building, and that's often to do with the types of materials. So there's the material red list, which includes a whole lot of harmful chemicals that you see on the right-hand side, and you would just be amazed at the fact that many of the common materials that we find have those sorts of chemicals. However, a lot of the natural materials don't, which it kind of seems quite an obvious thing. And so I'll talk a little bit later also about water management and energy particularly, because obviously that's one of the key pathways to net zero. Passive House, as David talked about, is a very strongly structured engineering approach to design, and I guess it's particularly to do with, getting a lot of those passive things, such as sun shading of north windows and east and west windows right, making sure that the envelope is very high performing, including through the windows, that there's no thermal breaks and no little gaps where the heat or cooling that you're putting into the house can dissipate into the exterior, and having a really efficient form of mechanical ventilation. That seemed kind of reasonable. I guess probably some of the things that initially prompted us to think a little bit more, and it didn't really change the way we approached the project, was just getting some of these key items that are really quite obvious, and they're not specific to passive house. But things like, for example, if you take a floor area on the left and you make it a very simple shape, you get a certain amount of wall length. The wall is the space through which the heating and cooling will transfer out into the atmosphere, and will create the need for heating and cooling. So you start to change the geometry, and the same 1,000 square meters in the middle area has substantially more wall length, and the one on the right has even more. The other thing that it does is that when you look at passive house, you really got to examine, because it's very engineering based, you've got to look at all the connections, all the corners. Every junction has to be analysed. Obviously, a very simple rectangle on the left has 4 corners. The same amount of floor area on the right has 12. And as I said, they're probably on the left, the typical passive house; on the right, probably more typical of what as architects like to do, and probably the approach we took on David and Kate's house.
I'll just jump in there quickly, Diego, and say this, that being mindful of the monopoly house, as it's called, or the rectilinear house, I did say to Wardles at the start, design for obviously all the normal passive requirements, as you would as an architect. But in terms of shape and form, I want a beautiful, John Wardle building. In other words, I didn't want Wardles to be constrained to the rectilinear. I wanted the beautiful building, because the engineers told me we could make it work one way or the other, and they did.
That's right.
I wanted to mention that.
No, it's good. That's a very good point. The other learnings, I think probably what systems like Passive House or Living Building Challenge do is they really put a very sharp focus on some very obvious things. So, for example, a space that's the same amount of space on the left in that block, very simple room, obviously takes a certain amount of heating and cooling to make work. The same space on the right takes more. So, of course, they're the kind of spaces that are also volumetrically interesting, and which are inspiring as bits of architecture. We also looked at things like various ratios, which really, without getting too much into it, it's just the amount of volume that you build can either be to surface area, can either be very efficient to heat and cool if you stack up the same amount and shared walls and roofs and the like, and of course if it's just a very flat blob that's very exposed on the right in that 2.8, it kind of shows you that it's just not performing as well. So there's some kind of very obvious things that come out of Passive House. The glazing is another one. Generally, keeping a very low ratio. You'll find the typical passive houses don't have massive areas of glass, and if they do, they're only generally on the north in our hemisphere, and not ideally not too much on the south, where you lose a lot of heat. So anyway, that was our own bit of research, and not something that we just thought we probably should start to look into it. And probably, I think out of all that, the main takeaway for us in terms of how we developed the design was its impacts on the Living Building Challenge and materials, because we thought that will definitely drive how we start to conceive the project. So as we do, David asked us to really look at the best way to lay the house on the block, and as you can see, the image on the top left is it's really the site plan, and kind of, I guess, a very initial concept idea for the house. And what became obvious to us was that where the house has this additional component of space, that was probably best suited to put the living spaces to give them a nice outlook. But we also saw a great benefit in creating this central courtyard as a heart of garden into the house. And we felt that that was really a good way, not only to bring north light and provide views from all the spaces, but also as a way of really just creating this idea of bringing the garden very deep into the plan, which we knew it was something that Living Building Challenge was very focused on in terms of biophilic design. So we did our site analysis, and some of the obvious things, as David said, they bought a block that had lovely north orientation, and so all the living spaces were generally oriented towards the north, with his courtyard in the middle. But then some other features started to be born from the site analysis. This beautiful Chinese elm, which was at the southeastern corner, became a really strong focus for the dining space. So you'll see how that developed into this idea for this wonderful window to look at that tree. And then probably one of the interesting ones was that in laying out the site, it became really evident to us that the bedrooms should be located on the west end of the property, so with the main public spaces on the east. That, of course, generated the two issues. One, privacy, because the property is at the end of Leighton Court. And at the same time, managing west light, west sun, which is probably one of the toughest ones to manage. So that started really driving the agenda for us concurrently. We started really looking in detail, as we do, at all the very fine measurements of how to fit David and Kate's brief, all the the bedrooms and kitchens and dining spaces and the like. So all these various things are all kind of running in parallel for us. I mentioned the Living Building Challenge because that was probably one of our main takeaways. Was about
house, by the way. I thought,
what's that?
Look, that's not the house, by the way.
No, that's right. No. So if you look, this is actually a reference to a beautiful house that most Melbourneian architects love, which is the Heidi House for the Reeds in Heidelberg, two artists, and a house by McGlashan and Everest. And I guess what was beautiful about it is that it's this incredibly beautiful limestone material that's extracted in the simplest way from a quarry in Mount Gambier. So they literally saw cut in 2 dimensions and literally extract the blocks in a really perfect module size. And that kind of, I guess to us, we looked at a number of materials. We looked at, I'll explain in more detail with the LBC, but in looking for really local materials, we explored timbers, we explored brickwork, and we explored this particular stone, and we landed on this as the material. I guess what that did is that suddenly for us, it really started to unfold this language of, once you start to actually develop the house, so this is the west elevation, as I mentioned before, the need for both solar control and also privacy. So we started to, I guess, develop this language of carving and cutting and sculpting stone as though a sculptor might be dealing with the material, and it is a beautiful material to work with in that regard. And so windows started to become almost crevasse-like openings through which you could kind of get light and see evidence of inhabitation, but still maintain our client's privacy. As we started turning the corner into the north elevation, of course, direct sunlight is more welcome, and we started carving larger openings up until we get to the a very significant opening in the middle, which is, as you'll recall, where we decided to create that central courtyard. And I think probably what was interesting at the time, and probably one of the very early things that we showed David and Kate, was just some ideas about the narrative of how this space might feel. So we referred them to this half-ruined castle, which is it's actually an indoor space. It's kind of partly open now, but I guess it was this idea that a space that's kind of partly outside, partly inside, reasonably architectural, but also got remnants of garden within it. It's almost a slightly vague in terms of its definition, and that became, I guess, a starting point for how we started to develop the nature of this central courtyard. And you can see David's study there floating in amongst a pond So just to take you through the plans quickly, there's a garage in a basement level, as well as a music and I guess entertaining room. The plant's a little bit more developed than this, but fairly significant plant areas, which is where all the all the real equipment is happening for for the grey water treatment, for the water filtration, for the mechanical systems. Then, as we work our way up into the ground floor plan, the client's main suite. So on the left, come in through the front door, and walk into effectively their own wing. So a bedroom with ensuite and a robe, as well as David's study with his outlook to the garden and the pond. Continue down a corridor, there's a powder room, and then the two main living spaces, which are opening onto the main garden space, and then the dining space and kitchen having this beautiful view back towards this very significant elm tree. And so even very early back in schematic design, this is something that we like to, we like to bring our clients along for the journey early. But because of Living Building Challenge, we knew we were going to look at the idea of timber windows. And we had also started looking at not just the limestone, but what our floor material could be. And so we had started already looking into this very interesting Queensland stone for the floor. So we actually brought a lot of these decisions forward that we would normally take a little bit later into the process. This is David's study. David's an avid book collector of art books and fiction and so forth. So we thought that beautiful space for him would be almost like a cave of books, so he'd be surrounded by the things he loves. The dining room would be a space defined not only by the limestone walls, which we carried through a lot of the ground floor public spaces. So the more public spaces were defined by limestone as a material, but then the timber windows, as well as this, we call it, I guess, a timber shroud. And I'll talk a little bit later about the material for that particular element. So then up a flight of stairs into an upstairs level. Probably what's interesting in terms of David and Kate's brief was that they were very keen to have a very nicely defined guest suite. They had a lot of visitors from WA. Perhaps some of you may get to visit. So this was quite a private wing for those guests, as well as a further 2 rooms with a bathroom and then an access into a roof terrace. And this was some of the early views that we showed David and Kate. So it's a very simple, very pared back palette of materials. So not only were the materials natural, they looked very natural as well. So having done that, I think David and Kate were very pleased with the outcome. Of course, then we got into the next phase, which is for us design development and documentation. And this was really just seeing how we could stretch both passive house principles and LVC in terms of working through our design and taking this into consideration. Some really high level type things, when you're doing minimum building code of Australia for a 6-star house, you get a certain type of performance that you've got to meet on the right. You can start to see some of the performance of the envelope on Limestone House, so significantly improved, particularly when you look at the glazing. Some of that was to do with meeting passive house requirements. Some of it also had to do with achieving, for example, some of our courtyard glazing in order to be able to have nice large areas of glazing to create that visual connection. We needed to improve the performance of the glass. So I mentioned before about that simple plan of a passive house. This was clearly not that compact and regular form. As you can see, was more that kind of, I guess that sort of increased facade area to floor area that has a purpose because it creates spaces. So for example, in this case, it creates this courtyard that's landscaped and looks at the tree. In this particular case, it's about creating the outdoor terrace. In this case, it's about defining a space for the dining room. So, or in this case, and this is a section through the dining room, it's about how to best encapsulate the proportion and of the existing tree so it can be appreciated. So always very good reasons for everything. I also mentioned that that simple rectangular plan had 4 junctions. Obviously, this one had a lot more. And in some ways, the AWST consultant delighted in showing us his first sketch where he bubbled all the different junctions that he would have to have a look at. And I'll talk very quickly through some of these. They're fairly technical things, but in Passive House, it's all about creating this continuous thermal envelope, like an esky, I guess. And so when we initially looked at it, our thinking was that we would put the insulation, this is a section on the left, that we would put the insulation below the slab, and then we would actually fit some steel to support the limestone. We rapidly realized that to create that, we would actually need these components to support, to connect the steel that supported the limestone to the slab. That would create fairly strong thermal breaks fairly regularly. And what we found was that these particular components, they do exist, but they're very expensive. And you have to bear in mind that Living Building Challenge put a limitation on how many things could come from overseas. So one of the really interesting things, well, we actually developed with the AWST consultant, Nick Mulvaney from UMLI, this really unusual method where we would actually effectively have the slab for the ground floor is what's called cold, and that pretty much cold means it's not treated, it's not heated or cooled. And then the basement spaces would basically have their own loop of insulation, and the ground floor would have its own uninterrupted loop of insulation. So that's how we got around being able to use limestone. If we were to have wrap the house in timber, for example, we probably could have done a simpler type of setup. And so that's effectively what we ended up with. So the red is the slab. That can be very simply connected. So the limestone is just fixed via fairly standard steel angles, and then all of the insulation is happening above that line. And so this kind of initially, just to give you a little glimpse on the process. So this is the orange line is the thermal envelope, and if you go and speak to Passive House people, they delight in that you can't be able to lift up your pen. So you've got to be able to draw this continuous line all the way through your section. And if you've done that, then you've achieved a continuous envelope. What that means, and this is some of our detailing work for some of the sections and the like. So on the right, this is a floor plan detail. So that's the insulation on the wall. Of course, architecturally, we still wanted to achieve the type of appearance that we wanted to achieve. So what you'll actually find is there's a reasonable amount of work that goes into achieving this continuous line of insulation through the windows and through really bespoke details. Similarly in section, which is this one on the left. Can people see my mouse as it's moving? Can you see that?
Yep.
Yeah. So what that's showing again is that the wall insulation travels through the high performing glass. There's insulation at the top, and that continues through the roof. So they're the kind of things, I guess, the overlays that are really very good practice. And I think you'll actually find that our industry is heading there. Whether we will be at this level in another 5 years or 10 years, I guess, is yet to be determined. But obviously, this sort of detailing is ahead of its time.
Gemma, just quickly, I guess it's a little bit hard in this short time, and I know we've got a lot to get through, but we're very happy to share those details. I'm very happy to share those details with anyone who's interested, because a lot of work went into them to create thermal breaks, and it wasn't simple, but
no, that's right.
Happy to.
Oh, that sounds excellent. We can chat after. Yeah,
that's good. So this, for example, just to give you an idea. So this is where those, I guess, glass crevasses in the west elevation are, and we wanted the glass to run all the way down to the floor. It's a detail that I guess would articulate the strong sections of stone from the windows, but of course is created just a detail to resolve to be able to get this orange, which is the thermal insulation, to be able to work. And obviously having to look carefully at all the different types of products available in the market to achieve what we were after. I'll touch very loosely on the thermal breaks that David mentioned. I mean, I look at kind of a typical one is the fact that to support the limestone, we needed steel columns. And that immediately, I guess some of the things that became really apparent when the ESN consultant was looking at is, well, where in that wall that's insulated do you put a steel column? You know, so do you put it externally, which of course you wouldn't because there's no insulation externally. That's the one on the left. Do you put it on the inside, which intuitively you think would be the would be the best in terms of a passive house, but it turned out that through analysis it was actually the middle one that actually proved to be the best. So we did a lot of this sort of analysis. When I say we, with the ESC engineer. The other thing, I guess that was kind of tricky for this particular project was the fact that, for example, this is the terrace from one of those upstairs bedrooms. I think I mentioned that we were really trying to provide each of those rooms with its own outlook. So that's the image on the right. In order to do that, there's actually a structure for the deck that sits above the structure for the main flooring. And often we would have these blue components, columns, that actually go through our thermal envelope. So there was a lot of analysis for how to treat those sorts of connections. So a lot of things, a lot of work went into areas you just do not see. What that means is a lot of coordination, a lot of, it's not like we were sitting with groups like that all the time, but that was one of these sessions with the builder, the prefabricator, the ESC consultant, the structural engineer, just to really, and the window manufacturers, just going through, they're the kind of meetings you typically would have in a normal institutional project, but not so common on a house like this. And similarly, looking at the glass and being very selective about the positions of the glazing on the plan, and just really looking at, and this became, I guess, an interesting form of research in its own right, because to meet passive house, we needed where you see the word Schuko, that's really high performing German extrusions, which are passive house certified. So when you hear the word passive house certified, it means it really does meet an incredibly high level of insulation. But of course, we wanted a lot of natural Australian and local components for Living Building Challenge. So we developed a whole lot of composite details. So for example, the timber window frames were made from recycled timber from Kempsey in New South Wales, beautiful recycled material, with then these details of the German high performance extrusions. Or in the case of the kitchen, we would have a high performance extrusion, but then decorated with a timber reveal. So in the plan detail and in the view, I guess the idea was to kind of create the appearance of a timber window as much as possible. All the sliding doors were made from the same recycled timber. They're all what's called a lift and slide window. That means that they seal at many different points. It's the best German technology for hardware, but again using Australian recycled timber material for them. One of the aspects of passive house is how you seal it. So this air tightness, and we had to look very carefully at all the details. There was a lot of prototyping. So the image on the right is a prototype for how you might actually connect the window frame to the lining, and the white that you see is actually an air tightness membrane, something you're starting to see a lot in institutional projects, but you almost never see it in a house. So the house was tested, and I think at about 1.08 air changes per hour, compared to a 6-star compliant home that you would build at the moment would typically have, as a base case scenario, about 15 air changes per hour, sometimes as bad as 25, depending on how bad it was built. So by comparison, a very badly built house that still meets today's code could be 4 times the amount of air leakage. So that's where you're losing a lot of your heating and cooling value. The next aspect is the ventilation system, which in a passive house is constant fresh air, but with heat recovery, that means that as you have actually a slow delivery of fresh air constantly going through the house, which creates a beautiful indoor environment. But as the spill air is taken out of the building, so obviously if you keep on adding air, you're going to overpressurize the building, so you have to release some of that air, but that air goes through a heat recovery unit, which in effect picks up the heating and cooling that you've collected and reuses it, so you don't use as much energy. David mentioned passive house being prefabricated, and again, this was not the standard prefabricated module that you typically see, which is 15 meters by 5 meters, because it kind of fits on the back of a truck. But just quickly, some of the benefits which David talked about was being able to run multiple construction streams, and one on site on the right while they were building the shell on the left. We could do a lot of testing before the components were needed on site. So that's the study that you see in the second image from the right, and testing all the insulation. Then working with Arcad, who are an architectural prefabricator, we started developing, I guess they broke the house into components. So there was some fairly simple two-dimensional components, and then some, where possible, three-dimensional components, which meant that the whole thing could literally be picked up, put on a truck and delivered to site and installed in the same day. And so this is some of the images of some of the more three-dimensional components that are the front elevations. You could literally see the whole front of the house getting built and tested in the factory, then pulled apart and put into trucks and delivered to site. So it's quite a fascinating process. And obviously, what that means is there's very good quality control, which for a passive house is paramount. You don't have the issues of dust when you're trying to tape up hundreds of linear meters of junctions. You don't have, obviously, you're not subject to wet weather. You don't want a lot of those panels getting wet. And there's a lot of checking through the shop drawing process that allows for good quality control. So just checking for time. So I think we're okay. Do you think, Gemma?
I think a little bit faster perhaps, because we can
Yeah,
always...
okay. Yeah, no, we'll race through it. So living building challenge, as I mentioned, is a very recuperative. So it's not just about offsetting or minimizing poor practice. It's really meant to be a very positive standard. And Leighton Court was not your typical off-grid site. It's not a greenfield site in the middle of a country or coastal area. And you could see to fit, there was a reasonable amount of brief to fit on the block. And as I mentioned, a lot of the things that we looked at were to do with materials, to do with the timber being local and FSC accredited, managing water all on site, and also creating more energy than the building would use, which I guess is a positive energy. So not even net zero energy, but actually a positive energy.
Diego, just a quick one on the red list. Oh, here we are. Move to that slide, but that was one of the areas of, I guess, which is newest to all of us, but we all knew that the adhesives, the caulking, the paint, and all the smelly materials were the risk, that the tanking for walls, etc., were the risky areas. We now have a full list of materials we use, which have no toxic materials. And again, Gemma, very happy to share that, as I have with other people in both this town and Perth. Very happy to share that with you and your colleagues as well.
That'd be excellent. Thanks, David.
Yeah, so from what David was saying, this is like a typical bit of a very significant spread list. You can see all the titles at the bottom. So they literally look at every single material on the project, every paint, every bit of waterproofing, and you can imagine all the timber complies quite happily, and all the paints and caulks, as David said, are tricky to resolve. Look, as an example, for example, PVC is a terrible material, contains a lot of the components on the red list. So as an example of how that kind of has an impact on construction, all the plumbing was high density polyethylene instead of PVC. It turns out that it's a much better and harder material to use, but it does have, it can have costs associated with it. The timbers, all locally I think LBC has a couple of kind of conflicting agendas. On the one hand, it's got to be fully FSC certified. For those who don't know, that's a Forestry Stewardship Council, very, very difficult level of certification to achieve for timber, or recycled or reclaimed. And that's generally where we headed down. So externally, all the cladding and all the windows were blackbutt from Kempsey in New South Wales, whereas all the internal linings are these hydro wood from Lake Pyman in Tasmania, where they salvaged trees from the hydro project there in the 1960s. So it's beautiful material and quite unique as well in terms of how the material looks from its time in the water. The materials had to come from a certain location, and we were aware of this at the very start of the project. So strong limitations. We are an island in the middle of nowhere, which has kind of served us well during the pandemic, but in terms of meeting living building challenge distances, it was a very big challenge. But that gave us a very strong focus to finding local things versus imported things. So we knew, for example, on the left that all these tricky passive house requirements or components were required, had to come from places like Germany. And that kind of meant that immediately we sort of looked at really, where possible, all the materials we were in control of being local. So it can be a limestone from South Australia, the Tasmanian and New Zealand timbers. And then for the floor, we looked at a Queensland siltstone. So pretty much everything you live in amongst in the living spaces is Australian derived. So this is a more recent photo of the limestone in its final incarnation with its landscape, and this is starting to look at the limestone as it's worked its way into the house, and you can see some of the Queensland stone. It's actually a really lovely match to the walls. Very quickly on water, the house manages all its own water. So without getting into too much detail, the diagram on the left is water is captured in a tank, gets a very strong level of filtration, and then gets used for all the potable water needs in the house. That's a diagram on the very left. The diagram on the middle is looking at all the water that comes from basins and showers. That gets treated within a grey water treatment plant to a very high level again, and that can then gets used to flush toilets, some irrigation, and the washing machine, and then finally the last cycle is from the toilets and the like. There's actually a black water treatment plant, which again, because the house is in a fairly, it's in a urban setting, it's a very high level of treatment. Typically you'd find these sort of systems out in larger rural or coastal blocks. Some interesting work that was done with aquaponics, combining a fish pond that's in the heart of the courtyard with some grow beds to really look at urban agriculture. That's something that the Living Building Challenge is very strong in. And both to meet the Living Building Challenge urban agriculture criteria, but also because David's wife, Kate, is a fantastic cook. So this has become a really fantastic kitchen garden on top of the dining room that gets north light all year round. And this brings us to the energy petal, which is, I guess, very much something that drives the operational aspects of getting the net zero energy achievement for the house. And this is where Living Building Challenge and Passive House work really well. Passive House is so incredibly efficient in terms of creating a really low energy demand envelope, about 60% compared to most houses, which kind of means that you don't actually need that much PV cells on the roof to actually offset the energy requirements. In terms of achieving this very incredibly high performing thermal envelope, again, that actually means you don't need, when you actually look at the air conditioning systems in the house, they're actually tiny compared to the ones that you would typically see for to treat a house of with spaces of this size. The air tightness makes a massive difference because you don't have, in the middle of winter, for example, you don't have a whole lot of heat escaping the house. So you're getting really true value for the heat that you're putting into it. And the heat recovery passive house system also means that, whatever heating you're creating, you're taking the benefit through the heat recovery system before you discharge the spill air out of the house. And I guess without going too much into it, there was a whole lot of work done on making sure the appliances are high efficiency, the lights are all LED, all domestic hot water and air conditioning are all heat pumps, latest technology to keep them very efficient. And I guess one of the things, and this was probably driven more by us, we thought that one of the ways to really drive energy use down was to make sure that we could daylight most of the house all day long whenever there was natural light. So we really took this approach as something that would obviously add to the quality of the space, but also something that would allow David and Kate not to necessarily have to turn on lights all the time. And this meant that, a 9 kilowatt solar array could service the house. That's all been installed. The batteries are, because of COVID, delayed, but they're yet to come. And some of the energy ideally will be surplus and be exported into the grid as a contribution to the city. So maybe David, if you want to talk, I'll maybe just page through some of the images of the finished building. And
well, if you move through the images, really, it's turned out that people who come here feel it's a very calm atmosphere. We think that derives from both the sealed nature of the house, because it's very calm and quiet, but also the two materials, the timber and stone. I was asked to write a few notes for Wardle, so I'll just read you what I wrote, just rather than rewriting it. The quality of space, simple materials, natural light and fresh ventilation leads to the feeling of a calm, healthy environment. The kitchen and adjacent dining areas work very well as communal hubs. Large glazed doors, a la John Wardle, a la Robin Boyd, provide ready access to external courtyards important for entertaining. Beyond these, the bedrooms and studies and bookcases, theatre room and all those areas provide really fantastic facilities for contemporary living. And just while you're on that slide, those basins, for example, are emblematic of why the selection of John Wardle Architects as our architect was a very good choice, because John Wardle's personal and the company's corporate culture is one of recognising and celebrating artisans and their work. So those basins, for example, are made in Tasmania by a terrific potter called Lindsay, what's the name, Diego?
Werrett.
Lindsay Werrett.
That's right. And all the bench tops were cast in situ concrete, again, so that they could be locally made.
Well, not sure, if you've got any more shots there might be one of the hallway with the cane. So John Wardle Architects do not like product. So that's the balustrade, which are actually vertically tensioned wires with cane woven in between, and that's a stiff balustrade, not absolutely stiff. But you can bounce off it if you fall into it at any particular point in time.
And it's, I guess, in keeping Living Building Challenge is very much about supporting fabricators and people and local industry, and also showing evidence of handmade. And so I guess a lot of the selections, whether it was the wicker or the vanities or the concrete bench tops, it was all about, I guess, showing evidence of that, or the timber handle on the doors, for example. I might race through, actually the lessons learned are probably important, but there's a few other things that I wanted to get through. I think one of the things.
Maybe just check time, Diego, with Gemma.
Yeah, Gemma, what do you think?
I'm okay, but I would love to talk about the lessons learned. I think it's a really important aspect, and I would love to hear what, as a practice.
Sure. Yeah, I probably have one other. I've got about another 6 slices on another job that follows this one. I thought might be interesting to just tell you how we've learned something. Yep. So one of the things that I guess probably starting to look into it. We didn't realize the savviness in the proposals from Mick Bishop about combining living, building challenge and passive house, because the two things just work so beautifully together in terms of both, being able to achieve a house that generates and captures and provides everything that it needs from the site. Obviously LBC achieves that, but in terms of creating an approach to operational net zero carbon, passive house is just such an incredible way of achieving a really high performing envelope, which means that you really don't need much energy to actually create a really comfortable living space. Also, the environment is very, it's just a very healthy indoor air environment. It's very comfortable, and that's, I think, a combination of the fact that you have a constant 100% fresh air ventilation that's part of the passive house system, but that combined with the living building challenges limitation on no harmful chemicals. There's no off-gassing, there's no nasty paint off-gassing or anything like that. Now, I think the other thing that we realize is that things like projects like this, and to achieve the kind of standards, you really need a highly collaborative effort from everyone involved, whether it's the client, the architect, the prefabricator, the builder, the material suppliers. Everyone has to work in tandem, like a fantastic orchestra, I guess, to be able to get to the end. The other thing we found is that you do need a far greater level of coordination and detailing. That is the case in the current business as usual approach. However, I think to David's point about sharing the living building challenge materials list that we've got, as databases for this sort of material start to grow and as processes become more established, I think there's going to be efficiencies that allow more projects to be able to head in this direction. The other thing I think is that as an office, we get to see a lot of big projects, and we are in an industry that tries to build as fast as possible, as cheaply as possible. Good practice like this does take time, so detailing and materials have to be carefully vetted. So it does place some limitations on changing things during construction, which I've got to say personally I don't mind, because it does mean you can have a really considered approach to things. I would also say that the project was also very well suited to prefabrication. I think prefabrication does have its place, particularly in terms of not disrupting neighborhoods and not, creating, limiting the amount of waste and other things that happen typically on a building site.